Today I am going to explain photoelectric transducer. First of all, what exactly are photoelectric transducer? They convert light energy into electrical energy. As we all know, our electrical transducer convert various types of energy into electrical energy. For instance, the photoelectric transducer, as the name suggests, converts light energy into electrical energy. These photoelectric transducers are made from semiconductor materials and they work by using photosensitive elements which release electrons when they absorb light. That basically how they function. Simple enough, right? So that basically how they function. Their function is simple enough. So photosensitive elements do their things, and whenever light hits them, they all emit electrons. That's how we utilize this property in our photoelectric setups. There are different types of photoelectric transducer available, and the most basic one is the photovoltaic cell. It is important to note that photoelectric cell captures light and convert it into electrons. Now let's take a look at its construction. We often refer uh, to its photocell or phototube. A phototube is a good example of photoimage transducer. Okay. So basically, here how it's set up. It includes a vacuum photoelectric cell made of glass. You can see here that is made of glass photoelectric cell. Inside here an anode and cathode. Okay, that is a anode here and that is a cathode here. So inside there an anode and cathode. We are going to use some photosensitive materials on this. Like we mentioned earlier, in this case the photosensitive material is calcium, antimony. After that the blast tube is evacuated, meaning a vacuum is created inside. So this is how the photo electric transducer look. Check it out. Here is the cathode. Why you see here is the anode. What you see here is the anode, here is the cathode. So and this assembly is set up inside an evacuated glass tube. Now you can see some of its terminal here. Okay, those are terminals here. First we indicated its symbol like this. Here is the anode and over here is the cathode. Now let's take a look at how it's work. This is our photo and our phototube. Okay, in the phototube there is a terminal. Okay, so in our phototube there is a terminal. Okay, you can see that the terminals for the anode and another for the cathode. In this case the connection is made like this. The anode is connected to the positive terminal. You can see here the anode is connected to the positive terminal and cathode is connected to the negative terminal of the battery. The battery does its job, and when the light flows, some electrons are emitted and the lights stay here, but due to the energy from the light, electrons are released. These electrons have a negative charge, and we have connected the anode here, and which has a positive charge. So the electron that come out from the cathode are attached to the anode, and once they get pulled to the anode, the current start to flow. That's how it's work. All right, check this out. So when light energy hits the phototube, you can see here it will start having some current issue. the more intense the light energy here, the more current will flow. This means we can say the next type of transducer is the photoconductor transducer. Okay, its working principle. Photoconductive transducer, um, uh, its working principle is pretty simple. When light hits it, the resistance changes. As soon as light hits it, the resistance goes up and down. So we can say it's light dependent. The resistance changes when light hits it. Basically, this work on the photoelectric effect that Einstein talked about. Uh, Here you can see it's an LDR. This is a LDR portion. This is a LDR. Okay. Um, so it's a mainly it's a LDR portion, uh, or we can also call it photoconductor transducer. In this case, look at the terminals and connecting pins. This part is called electrodes. So this part is called electrodes. Okay. And we have used photosensitive material here. That is the material you can see here. That is the material, and that material is cadmium sulfide or cadmium selenide. These two are semiconductor material, and the semiconductor material has a zigzag pattern applied to it. So along with that, there is a ceramic based base provided, which act as a photo. Okay, this ceramic, okay, portion act as a ceramic base provided, which act as a photoconductor transducer. Its symbol looks something like this. So see, there is a light that is shining on it, and the resistance is also flowing it, which forms the symbol of LDR. Now in this case, we will take a look at how it's work. We have set it up here, and these two terminal has a show previously are maintained in this case. This terminal will be connected here in a way the positive is linked with the negative, and once that done, the current will start flowing as soon as the light hit this photoconductive transducer. Normally this current won't flow to the floor. Usually we provide a supply all the way to the old ones, and then the deflection type material will allow the current to flow, which will show us the direction. That is why the direction. Okay, show us the direction. So which will show us the not direction, deflection, sorry. Now let's look at the advantage and disadvantage of photoconductive transducer or LDR. This photo of photoconductive cells is about cadmium selenide using cell phone. So we can use it for infrared regions or regular light. I mentioned cadmium selenide earlier. If you want to use it for infrared, then that's what you will get. But there are drawbacks to photoconductive transducer. Their resistance varies due to the temperature changes. If the temperature changes, the resistance will change too, which affect the light value. Also cannot be used for the N-long application, is more suited for the analog application. Okay, analog application, you cannot use it for that, so that our applications for we can use it as a burglar light control switch, or for controlling circuit. We can also use it and measure light intensity, and finally we can use it to count objects, like when we need to count the number of packages during packaging. The next type, which is photoelectric transducer. is a photo and type cell, that is photoelectric transducer. So essentially when we talk about voltage here, it means generating electricity. What this cell does, it generate output in electric voltage. It's basically an active transducer that converts light energy into electrical energy. We know that the solar panel convert light energy into electrical energy, so we can say that solar power lights are more effective. These kinds of material are commonly available for us here. It uses single crystal silicon or photocrystalline silicon or sometimes cadmium sulfide. Most of time silicon is the material that use. The symbol for the photo and type of cell looks something, you can say, you can see here, mm, um, like light this, showing positive and negative. The positive and negative you can see here, which indicates the battery. The lights here represent incoming energy, meaning it's falling, and then we can see how it's works. Just look at the diagram. Whenever there is a solar radiation, the electrons here will start moving. Electron is start moving this direction, start to moving the direction. Now till we will start the current flow here. So you see that we have connected one side of the electron side, and the other side, the NP side, is hooked up like this. So the side with the electron is the p side, and which means we will have holes here. This way the positive and negative current can flow. As soon as the current start flowing, we can either connect it a load directly or use it to charge a battery. So that's how a photo shows how a cell works. Let's look the advantage of using external energy sources. We know that external energy can be used as an energy converter, like uh, uh, turning solar energy into electrical energy. So this is applied in spacecraft, data processing industries, switching and trigger circuits, or any related application. So it can also be used determine material processing. Lastly, it can even be used musical applications. So all of these are related to photoelectric technology. So that's all for photoelectric transducer. Thank you.